Okay, I will explain about the key international and national standard for electrical machine safety. Okay, there is four standard. First is IEEE, which is Institute of Electrical and Electronic Engineer. Second is NEC, which is National Electric Code. Third is IEC 60034 series, and OSHA, Occupational Safety and Health Administration. Okay, IEEE provide international standard to ensure the safe and efficient design, testing and operation of electrical machine. Okay, IEC, a global standard for rotating electrical machine covering design, performance and energy efficiency. Okay, OSHA set workplace safety regulation focusing on electrical hazard to protect workers during machine operation and maintenance. NEC outlines safety requirements for the installation and operation of electrical machine, particularly focusing on AC and DC system. Okay, I will explain two examples for each standard. For IEEE is IEEE 112, Standard Test Procedure for Polyphase Induction Motor and Generator. Okay, it specifies method to test motor performance including efficiency, torque and power under various conditions. The application is engineered in a manufacturing plant tests a newly procedure motor to verify its efficiency meets project requirements before installation. Okay, the second example is IEEE 43, recommended practice for testing insulation resistance of electric machinery. Okay, it provides guidelines for testing the insulation resistance of motor and generators to avoid electrical breakdown. The application is maintenance personnel regularly measure the insulation resistance of a generator using IEEE 43 procedure to ensure safe operation and prevent unexpected failure. Okay, second is IEC 60034 series, which is International Electronical Commission. For the example is IEC 60034-1. Okay, general specification for rotating machine. It explains that define operational parameters like temperature limits, voltage tolerance, and mechanical strength for rotating machines. Okay, the application is a factory installed motor that comply with IEC 60034-1, ensuring they can handle the facility's variable operating conditions safely. Okay, the second example is IEC 60034-311, energy efficiency classes for motor. It is for classifies motor into efficiency level like IE1 to IE4, encouraging the use of more efficient machine. Okay, the application is a company replaces its IE2 motor with IE3 model to reduce energy costs and comply with government energy efficiency. Next is OSHA, which is the example is OSHA 1910147, which it means for lock out and take out, in short, LOTO procedure. It explains that requires isolating machine from energy sources during servicing to prevent accidental startup. Okay, the application is technician repairing motor, lock out its power source and take it to prevent accidental energization while they work. Okay, next example is OSHA 1910303. It is for electrical safety requirement for installation. It explains that regulates the safe installation of electrical system, including proper grounding and circuit protection. Okay, the application is an electrician installs a motor with correctly rated circuit breaker and grounding in compliance with OSHA 1900303. Okay, lastly is NEC. The example is NEC Article 430, which is for motor circuit and controller. It specifies overcurrent protection, wiring, and disconnecting means for motor. Okay, the application is during motor installation. An electrician Okay, for IEEE standard purposes is the IEEE standard provide technical guidelines for the design, testing and operation of electrical machine. They aim to ensure performance, safety and reliability while supporting innovation in electrical engineering. Okay, the relevance of electrical machine operation is ensuring that machines are tested and operate as per defined technical parameter, reducing risk for failure, and promotes compatibility between component and system, especially in industrial environment. And the example is an IEEE compliant motor is more likely to meet performance requirement and integrate seamlessly with control system. Okay, for IEC 60034 series, the purpose is this series standardizes the construction, testing and performance criteria for rotating electrical machines such as motor and generator. It also includes energy efficiency classification, example IE1 to IE4. Okay, the relevance of electrical machine operation is improve the quality and safety of rotating machine by providing globally recognized specification, help engineers select machine.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ammar bin Saifullah. My number matrix is B112310336. Okay, now I will talk about my point. Is the legal compliance requirement for electrical machine. Okay, now let me talk about it. Why legal compliance matter? Firstly is to ensure the safety of workers and the workplace. The second is for electrical machine, especially high voltage system, requires strict compliance to avoid hazard. And third is to prevent accident, equipment damage, and legal consequence. So this is why legal compliance matter. So these three reasons. Okay, next, legal requirement in Malaysia. Okay, first we have Occupational Safety and Health Act, or we can call it OSHA. 1994 is ensure to a safe working environment. Second, Energy Commission or Suruhanjaya Tenaga is oversees electrical installation and certification. And third is Electricity Supply Act 1990 is regulate to safe use of electricity and machinery. Okay. And for the safety requirement, machine must be installed by certified professional. In Malaysia, we have SIRIM. Like for the second one is regular inspection and certification SIRIM, as I say. And employers must provide training and safety measure for worker. Okay, next, essential safety protocol for electrical machine. First, lockout and take out procedure. Okay, this procedure we can define as a process to isolate energy source and prevent accident machine operation during maintenance or repair. So if the worker need to do the maintenance, we need to do the process lockout and take out. So that we'll talk about the step of the lockout and take out. Okay, this is the diagram of the process lockout and take out. First, we need to preparation. So this preparation is identify types of energy source, use potential hazard and all control device. Second is to notify all affected employers. Third is to turn off or shut down all operator controls. And fourth is to isolate all the energy source. And for the fifth is to lock out all switches and energy control in the off or safe position. And for the sixth is to take out, or we can say take out to be employer in all cases where a lock is present. And for the seven is to zero energy or ensure that any dissipate energy is safety relief and cannot be reaccumulate. And for the eight is to try out or test the operating control, be sure nobody can get hurt before the testing. And for the nine is the completion to complete all the tasks, ensure vigilant observation as is continued. Okay, for the lastly is to restart all equipment, or we can say is recharge. Okay, back to the slide. For the grounding requirement, okay, firstly is to provide a safe path for the fault current and is comply with MS, or we can say Malaysia Standard IEC 6036. So Malaysia for the this code is to measure the electrical system for in the building. So this is the meaning of the this code MSIEC 0364 is for electrical system in building. So for the insulation standard is to prevent short circuit and ensure safe operation, and it's meet the IEC 634 requirement. So IEC 634 requirement is a global standard for machinery or rotary equipment lah, like machine. What is the standard requirement for the machine and the rotary like that. Okay, next. Okay, we talk about the safety measure for DC and AC machine. Okay, for the DC machine is require proper insulation and cooling to prevent overheating. And regular maintenance of pressure is essential. For the AC machine, grounding and overcurrent protection prevent electrical hazard. And emergency stop system are mandatory for safety. And safe measure is to lock out and take out ensure for the safe maintenance. And operator must use PPE like glove, Google, and helmet. This like that. Okay. This is the compression table for the safety measure to the DC and AC machine. Okay, for the insulation DC machine is a high current protection and AC machine is voltage surge protection. For the grounding, DC need to effective grounding circuit and AC need to dedicate grounding system. For the protection device, DC is the simple fuse and AC is a circuit breaker or and VFD. For the maintenance, DC machine use a brush check, cooling system check, and AC machine is emergency stop system and inspection. Okay, this is the comprehensive for more understandable about the DC machine and AC machine safety measure. Okay, for the certification and compliance. First, in Malaysia, like I just said, we have SIRIM certification. It is issued by SIRIM CAS International, Malaysia National Certification Body. It's mandatory for products sold in Malaysia to ensure consumer safety. So we all know if we want to buy the anything electrical product, we need to check. And this logo at the product to make sure is safe to use. And two is the CE marking for the Europe. So this is the uh, safety mark for the product in Europe. Also we can see it. It's required for products so in the European Economic Area, or we can say is EEA, and it enable free movement of good within the EEA or in the European Economic. Okay, next is ISO certification. Okay, we have this ISO certification. First is the ISO 9001. It's focused on quality management system. And for the ISO 45001 is addresses occupational health and safety management. This ensure global standard for safe and efficient manufacturing process. So that is about the global standard, or we can say ISO certification. Okay. Okay, that's all from me. Thank you.
Assalamualaikum. My name is Nur Najiha binti Mustafa Kamal. Number metric B1123104112. I am going to present about a hypothetical situation in which an engineer needs to ensure that a new AC or DC machine installation comply with safety and rigor requirement. A manufacturing facility wants to increase the effectiveness of conveyor system by installing a new AC motor. In order to reduce risk and stay out of trouble, the responsible engineer must make sure that the installation conform with safety standard and regulatory requirement. The step the engineer should take to comply with standard and regulation from installation to operation is number 1, initial planning and evaluation. They need to determine the legal requirement, which is consult pertinent national, international and local standard including IEE, OSHA, IEC and and FPA 70E for electrical safety. Next, evaluation of risk. To find possible risks like electric shock, overheating or fire, do a risk analysis selecting equipment. Verify that the selected AC motor satisfy efficiency requirement is suitable with the planned power source, and process safety certification from manufacturer. Number 2 is documentation and system design, which is mechanical and electrical design, make comprehensive wiring, grounding, and integration schematic for current system. Safety feature include safety guards such emergency stop mechanism, overload protection, and circuit breaker. Next, record. Create a design report that include requirement for compliance, safety precaution, and specification. Also, approval. Send design for approval to the appropriate authorities such as Regional Energy Regulatory Agency. Number 3 is setting up for pre-installation, which staff should be in training, educated the installation crew on safe handling technique, compliance requirement, and other related topic. Site preparedness. Examine the installation location to make sure it satisfies environmental standards such as suitable grounding, infrastructure, sufficient room, and adequate ventilation. Check for compliance. Check that every part, wire, switch, enclosure comply with legal requirement. Number 4 is the producer for installation. First, observe the rule. Follow the manufacturer instruction and any applicable requirement while installing the motor, such as correct torque for mounting, alignment, and wiring. Safety measure. Make sure employee utilize tool approved for electrical installation and personal protective equipment (PPE). Analyzing during installation. Keep an eye on the procedure to make sure that safety rule and the authorized design are being followed. Number 5 is examination and commission. Perform safety assessment. Conduct a number of electrical tests such as leakage current, earth continuity, and installation resistance. Next, check for safety measures such as heat, sensor, and overload protection. Functional testing. Operate the motor to confirm its performance under various load and circumstances. Certification by a third party. Hire a certified inspector to provide a compliance certificate, guaranteeing that safety and regulatory requirements are being met. Number 6, record and acceptance. Assemble document. Keep track of all certification, inspect report, and test result. Obtain consent before beginning operation. Submit the paperwork to the appropriate authorities for final preparation. User guide. Give operator a thorough manual that cover maintain operation and safety procedure. Lastly, number 7, maintenance and operation track performance. To find and fix any operational problem, do preliminary monitoring. Make a plan for maintenance, plan for routine preventative maintenance and inspection. Adopt of compliance, review the system of a regular basis to ensure that it continues to meet safety and legal standards.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akif Umar bin Mahazir. My matric number is B1123100414. So today I will present to you on reflection on adherence to standard. So what is standards? Standards are established rules, guidelines, or protocol that helps ensure quality, safety, and consistency in process, product, or service. This can be technical or regulatory. So why is the adherence to standard is important? So for the first reason is quality assurance. Quality assurance to ensures the product and the service meet requires level of safety, reliability, and efficiency. For example, the medical device must adhere to FDA standard to guarantee safety for patients. For second reason is trust and accountability. Trust and accountability is to build confidence in customers, clients, and stakeholders that the works is reliable and ethical. For example, ISO standard is manufacturing, improve customer trust in product quality. For the third reason is legal and regulatory compliance. Legal and regulatory compliance is to avoid legal risks, fines, and potential accidents by following mandatory standards. For example, OSHA standards ensure workplace safety to avoiding accidents and legal consequences. So we move to challenges in adherence to standard. For the first challenge is balancing innovations with rigid protocols. Strictly standards of balancing innovation with rigid protocols can limit creativity or innovation, particularly in industries like technology. For example, in software development, standards ensure security but might restrict innovative approach in coding. For the second challenge is pressure to bypass standards. Professionals may face temptation to cut corners to save time and reduce costs. For example, ignoring safety standard in construction to meet a project deadline could result in accidents. So we move for a real life impact of adherence to standard. For positive example is aviation industry. Adherence to strict aviation standard has resulted in one of the safest modes of transportation. Example, regular check and adherence to standard prevent accidents and ensure the safety of passengers. For the negative example is manufacturing. Manufacturing is failing to follow product quality standard can lead to defective product and harm a company's reputation. For example, the 2010 Toyota recall due to non-compliance with safety standard led to financial and reputational damage.